Next we will see the Newton-Raphson method for the load flow studies. So here also the first step, it is same as the Gauss-Seidel method. You have to number the buses. Okay, so numbering of buses. What you have to do, just like in the Gauss-Seidel case, the slack bus you have to take as bus number 1. Okay, and the PQ buses you have to name next, number next. Okay, so this will be from bus 2 to P plus 1, given that there are P number of PQ buses. Okay, and the PV buses you will name from bus P plus 2 to N. Okay, because N is the total number of buses present in the system that we are dealing with. Okay, so this is the first step. The second step is to assume the initial values. Okay, assuming initial values. For PQ bus, you are going to assume the magnitude of voltage and the voltage angle, and for PV bus only the voltage angle, that is delta, you have to assume. Okay, next step 3, now you have to start the iterations. So here for the rth iteration, you have to find first the active power of the ith bus superscript r minus 1. So why we are taking r minus 1, it will become clear to you. So this you have to find for all of the buses except the slack bus. Okay, for PQ and PV buses, and you also have to find out the reactive power for only the PQ buses. Now how are you going to find these values? We are going to use the power flow equations, right? So the power flow equations from power flow equations. So what are the power flow equations? Pi r minus 1, so we will take it as the calculated value. See, these are PQ buses, that means the P and Q will already be specified. Okay, so we are making a distinction with this, whatever we are calculating, that we will call as calculated value, and whatever is mentioned, that we will call as the specified value or the scheduled value. Okay, so this calculated value you are going to write as, this is equal to sigma j is equal to 1 to n mod Vi r minus 1th iteration, Vj r minus 1, Yij the admittance, cos theta ij plus delta j r minus 1 minus delta I r minus 1, right. So this will be the expression for the power, the active power. Similarly, you can calculate the reactive power. The calculated value will be equal to minus sigma j is equal to 1 to n mod Vi r minus 1 mod Vj r minus 1 mod Yij sin theta ij plus delta j r minus 1 minus delta I r minus 1. So remember, this is for PQ and PV buses, while this is only for PQ buses. Now the next step, step 4, here you have to find out delta Pi and delta Qi. Okay, so that is going to be delta Pi of r minus 1, superscript r minus 1, this is equal to the power that is scheduled or specified, right. For the PQ bus, whatever value is specified, that is the scheduled power, minus Pi r minus 1 calculated. Okay, so this you can write, this is the specified for PQ bus. Okay. So this you are going to do for both PQ and PV buses, delta Pi. Okay. Now similarly the reactive power delta Qi R minus 1. So this is going to be Qi scheduled minus Qi R minus 1 calculated. Okay. So this is for what? Only for the PQ buses. Okay. Now these differences between the scheduled and the calculated values, if it is less than a certain tolerance level, so it might be mentioned in the question, if it is less than that tolerance level, then the iterations can be stopped and directly we can go to find the power flow from the power flow equations. Okay. But if it is not less than the tolerance limit, then we have to go to the next step. Okay. So here you can write down, if these values are within the specified tolerance, then iterations can be stopped, else go to step 5. That is the next step. So what we are going to do here? We are going to form the Jacobian matrix. So form the Jacobian matrix. Now we will see what this is. So here you have, we are just representing as a smaller matrix, but these are submatrices. Minus J11 is a submatrix, minus J12, minus J21 and minus J22, and here you have delta delta, and this is delta V. This will be equal to delta P delta Q. Okay, so this is the equation that we are basing our iterations on. Now what are these J11, J12, J21? So here minus J11 R minus 1 superscript, this is going to be equal to the differentiation, the partial differentiation of the active power with respect to delta. Now this is done for the PQ and the PV buses. So like I said, minus J11 is a submatrix. So we will see what is that submatrix now and how many number of elements are present. Okay. So this is going to be dou P2 by dou delta 2. So R minus 1, I am not writing the superscript as of now as it will get confusing. So I am just writing this main expressions. Okay. And similarly the power at second bus you are going to differentiate by dou delta 3 and so on till dou P2 by dou delta n. Okay. And similarly the next bus dou P3 by dou delta 2, and this is going to continue again till dou P3 by dou delta n. And what will be the last row here? This is going to be dou Pn divided by dou delta 2, and this is going to continue till dou Pn divided by dou delta n. Okay. So this will be the entire matrix. Now you can see how many number of rows and columns are present. So if you see here, we are using all the PQ and the PV buses, right? So this is going to be, the number of rows are going to be from 2 to n. That means you can either write as n minus 1 or you can write as p plus q. Okay. So this is going to be p plus q into, and what about the number of columns? So this will depend on delta, right? Delta is from 2 to n. So this is also p plus q. Next is minus J12 R minus 1. So this is the partial differentiation of the real power with respect to the magnitude of voltage. But this is done only for the PQ buses. Okay, so you are going to get the sub matrix here, dou P2, dou V2, and so on till dou P2, dou Vp plus 1, right? That is P number of PQ buses. So you can enlarge it a little. So like this it is going to continue till dou Pn, dou V2, and so on till dou Pn, dou V plus 1. Okay, so this is the subscript here, P plus 1. Okay, so this is the submatrix, and here you can see what is the number of rows that you have. Number of rows anyways it is P plus Q, but the number of columns, this is going to be only P. Next, minus J21 R minus 1. So this is equal to the differentiation, the partial differentiation of the reactive power with respect to the angle, voltage angle. So this submatrix you can write as starting from dou Q2 by dou delta 2, and next the same reactive power dou Q2 with respect to dou delta 3 now. Okay, and it is going to continue so on till dou Q2 by dou delta n. Similarly, dou Q3 by dou delta 2, and it is going to continue like that. The last row is going to be dou Q P plus 1, because we are only doing for the PQ buses, divided by with respect to dou delta 2, and this is going to continue till dou Q P plus 1 with respect to dou delta n. Okay, so here you can see what will be the order. The number of rows, it is going to be only P this time. Okay, and the number of columns, it is going to be P plus Q. And finally you have minus J22. This is going to be the partial differentiation of the reactive power with respect to the magnitude of the voltage. So here the submatrix is going to be dou Q2 by dou V2, and so on till dou Q2 by dou V plus 1. Okay, and the last row is going to be dou Qp plus 1 with respect to dou V2, and so on till dou Qp plus 1 by dou V plus 1. Okay, so this will be the submatrix. Now what will be the order of this matrix? The number of rows here is going to be P, and the number of columns is also going to be P. From here in fact you can get the order of the actual Jacobian matrix. What is the Jacobian matrix? J is minus J11, minus J12, minus J21 and minus J22, right? Now here what will be the number of rows? This will be the number of rows of minus J11 and number of rows of minus J21. Okay, so if you remember, the rows of minus J11 is P plus Q, plus the rows of number of rows of minus J21 is P. So this is going to be 2P plus Q. And what about the number of columns? This is equal to number of columns of minus J11 plus that of minus J12. Okay, so here this number of columns of minus J11 was P plus Q and J12 is P. So you are going to get 2P plus Q again. So you are going to get a square matrix of order 2P plus Q into 2P plus Q. Next, step 6. If you remember, we have wrote an equation like this: minus J11 minus J12 minus J21 minus J22. Here you have delta delta, delta V, and this is equal to delta P and delta Q. Now what we did, we have already found out delta P and delta Q. This is the scheduled or the specified power minus the calculated power. So this we have found out. Jacobian matrix also we have found out. Now what we have to do? We have to solve for these variables. Okay, solve for delta delta and delta V from the following matrix equation. Now here what we are going to get? We are going to get delta R, R minus 1 superscript, okay, and delta V, mod delta V, right, R minus 1, okay. So we are doing the rth iteration, but we were using the superscript R minus 1. So why we are using that? Here you have to finally get delta R, okay. The rth iteration of delta will be equal to delta of R minus 1 plus delta delta R minus 1. So that is why we have been taking the superscript R minus 1. We need the final expression this. Similarly, we are going to get the rth iteration voltage of the magnitude of voltage. So this is going to be mod V R minus 1 plus delta mod V of R minus 1. So these are the two values that need to be obtained. Now here, if the voltage limitation, sometimes for a PQ bus, the voltage limitations will be given, the minimum and the maximum allowed voltage. In that case, we have to change the calculated values accordingly, okay. If limits of voltage are specified for a PQ bus, okay, then if calculated values of voltage violates the given limits, then what we are going to do? In the first case, if Vi of R calculated is greater than Vi max, then we are going to simply take VIR is equal to Vi max. Similarly, if the calculated value is less than Vi minimum, in this case we have to take the rth iteration as Vi minimum, okay. So once this step is completed, step 6 is completed, then we have to go back to step 3 for the next iteration, okay. So here go back to step 3 for next iteration. So when will the iteration break? If you remember here in the previous steps somewhere we have, here you can see, if these values are within the specified tolerance, then iterations can be stopped, else go to step 5, okay. So this is how you get out of the iterations. Now once you have completed all of the iterations, then what will be the final step? You have to calculate the injected load flow into each transmission line. So this here Ij, just like in Gauss Seidel, this is going to be Vi minus Vj into Yij plus Vi into Yij naught. And what will be the complex power Sij? This is going to be Vi into Iij conjugate.